Name each polyhedron. The two on the left are both prisms. That's because they have two parallel polygonal bases that are connected by rectangles. The one on the left is a triangular prism, and the one in the center is hexagonal. Remember, we have a first name and a last name for these polyhedrons. The first name is telling you something about the shape of the base. The one on the right is a pentagonal pyramid. It's a pyramid because it has one polygonal base that is connected to a vertex opposite that base by some edges, and the faces that are not the base are triangles. Now, it may not look like a pentagonal pyramid because it's been turned. So if we turn it this way, it probably looks more familiar. Don't forget that you can always turn your paper when you're looking at these figures to get a different view of them that might help you determine what you're really looking at. Name each of these Platonic solids. We have a tetrahedron, a cube, an octahedron, an icosahedron, and a dodecahedron. Name the polyhedron formed by each net. These two are both prisms. We can tell that because there are two faces that, if we folded this up, would be parallel to each other. In the case of the triangular prism, it's the triangles, and in the case of the octagonal prism, it's the octagons. And those two faces would be connected by rectangles. These two are both pyramids. There's only one base that would then be connected to the vertex with those triangular faces. Count the number of faces, edges, and vertices for each polyhedron. Then verify with Euler's theorem. The triangular prism has 5 faces, 9 edges, and 6 vertices. And 5 plus 6 equals 9 plus 2. The hexagonal prism has 8 faces, 18 edges, and 12 vertices. And 8 plus 12 equals 18 plus 2. And the pentagonal pyramid has 6 faces, 10 edges, and 6 vertices. 6 plus 6 does equal 10 plus 2. There's 4 problems here that involve pyramids or prisms, and you know something about either the faces, the edges, or the vertices, and you have to find one other piece of information. See if you can find the missing information for each one. So the first one has 28 edges, the second one has 21 edges, the third one has 10 faces, and the last one has 11 vertices. Find the surface area and the volume of this figure. The surface area is 72 square units, and the volume is 36 cubic units. Find the surface area and the volume of the cylinder. For surface area, we need to find the area of the two circles, So we have 2 times pi r squared, 2 pi times 4 squared. And we need the surface area of the curved surface around the side, which is 2 pi times the radius, 2 pi times 4, times the height of the cylinder, which is 9. So that's a total of 104 pi square units. For volume, we need the area of the base, pi r squared, pi times 4 squared, times the height, which is 9, for 144 pi cubic units. Find the surface area and the volume of the cone. For surface area, we need the area of the circle on the base, which is pi times 3 squared, pi r squared, plus we need pi times the radius times the lateral height, which is pi times 3 times 5, for a total of 24 pi square units. For the volume, we need 1/3 times the base area times the height, which is 1/3 times pi r squared times the height of 4, which is 12 pi cubic units. Find the surface area and volume of the prism. Since this is a rectangular prism, we can find the area of each of the rectangles and then double the area because we know that there are 2 identical rectangles of each size. So there's 2 rectangles that are 9 by 5. There are 2 that are 2 by 5, and there are 2 that are 2 by 9. So we have a total of 146 square units of surface area. For volume, we'll take the base area times the height. So the base area is 9 times 5, and the height is 2, for 90 cubic units of volume. Find the volume of the prism. Since the prism has triangular bases, we need to find the area of each triangle, which is 1/2 times 4 times 9, times the height, which is the distance between the triangles, and that's the 5. So the volume is 90 cubic meters. Find the surface area and the volume of the regular pentagonal prism. For surface area, we need the area of each pentagon. So if we divide the pentagon into 5 congruent triangles, we can find the area of each triangle by taking 1/2 times 8 times 7. We have 5 triangles in a pentagon, so we'll multiply that times 5, and there's 2 pentagons, so we'll multiply that times 2. Plus we have the 5 rectangles around the sides, and the rectangles are all the same because the pentagons are regular pentagons. So each rectangle has dimensions of 8 by 10, and we have 5 of them, so the area of the rectangles is 5 times 8 times 10, for a total of 680 square units of surface area. For the volume, we need the area of the pentagon, which is 1/2 times 8 times 7 times 5, times the height between the 2 pentagons. So we take that times 10, and we get 1,400 cubic units. Find the volume of the pyramid. The volume of the pyramid is 1/3 times the base area times the height, which in this case is 1/3 times 3.4 times 3 times the height of 9, which is 30.6 cubic meters. A cone fits exactly inside a cylinder. If the volume of the cone is 30 cubic millimeters, what is the volume of the cylinder? So you might remember that the volume of a cone is 1/3 of the volume of a cylinder that has the same base and the same height. So that means that the volume of the cylinder is 3 times the volume of the cone. It takes 3 cones to fit inside one cylinder if the cone and the cylinder have the same base and the same height. So in this case, we know that the cone has a volume of 30 cubic millimeters, so the volume of the cylinder is 3 times that, or 90 cubic millimeters. This timer contains sand, which falls at a rate of 40 cubic millimeters per second. What's the volume of the sand in the timer? And how many seconds will it take for the sand to empty from the top of the timer to the bottom of the timer? Well, since it's a cone, we can find its volume by taking 1/3 times pi r squared for the area of the base times the height of the sand, which is 24 millimeters. So we have a volume of 512 pi cubic millimeters. Now for part B, we're going to take that 512 pi and approximate it by replacing pi with 3.14. So we have a volume of approximately 1,607.68 cubic millimeters. And if the sand falls at a rate of 40 of those cubic millimeters per second, we simply divide the volume by the 40 to get 40.192, or approximately 40.2 seconds for the sand to fall from the top to the bottom. There's 3 constructions you'll have to be able to do on the test. You'll have to construct a semicircular arch, an equilateral pointed arch, and given a circle, you'll have to inscribe a trefoil inside the circle. All 3 of those constructions are on the most recent video, which is lesson 7.1. So take a look at that video if you need a refresher on how to do these constructions.